So we're going to continue solving exponential equations. Let's move down to problem number 36. 7 to the x over 2 equals 5 to the 1 minus x. Now, this is a good example of a problem where it's like, okay, well, gee, what base logarithm do you want to choose? There's not really a good answer. And for myself, I'm just going to do base 10. It's not really worth it to do log base 5 or log base 7 because you're not going to get everything to cancel out nice and neatly. So let's just do base 10. So what's going to happen if I do log base 10 on both sides? So that's log of 7 to the x over 2 equals a log of 5 to the 1 minus x. There's a couple tricks in this problem when we solve it. You should try and catch both tricks because you will need them. So at home when you're solving these problems, there'd be problems like 31, 33, 35, etc. You'll need these tricks. What should you do first? Perfect. Let's use your power/parachute rule. Move the exponents out in front. So that gives me x over 2 times the log of 7 equals 1 minus x times the log of 5. Now I strongly suggest that on the right hand side that you bring out that 1 minus x in parentheses. Because if you don't write it in parentheses, then it looks a lot different. It is a lot different. It means something much different. Let's see. You could. But let me do this first. Let me distribute the log to both of these terms in the parentheses. So I'll keep this as x over 2 log of 7 equals the log of 5 minus x times the log of 5. Now these aren't like terms. I can't really do much with them other than factor out the GCF if I wanted to, but that'd be putting me back here. Now I had a suggestion to multiply both sides by 2. Sure, let's multiply both sides by 2. And that clears out the fraction here. So that's not a bad thing. So if I multiply everything by 2, I'm just going to write a 2 out here. And that's going to distribute itself to this term, and this term. Then what happens? Well, I get x times the log of 7, because the 2's cancel, equals 2 times the log of 5 minus 2x times the log of 5. It still looks like a big mess. Now, I said there was a couple tricks in this one. The first one was to distribute here. The next one's coming up after a couple more steps. But distributing allows you to move these terms wherever you want them. And especially now that we got rid of the fractions here, let's move some terms around. I'm going to move this term to the left-hand side. Can someone suggest why? Yeah, it makes it positive, and because then it gets all my x's to the left-hand side. So I got x log of 7 plus 2x log of 5 equals 2 log of 5. Now what's nice is that I've got all the x's on one side, here and here. But what's not nice is I don't have the x's together by themselves yet. I want just one x. I don't want x here and there and everywhere. I want one x. So here's the second trick. Well, we can't really combine these because these aren't the same term. I got a log of 5 and a log of 7, so we can't quite combine them. I think I had... Perfect. Thank you, sir. X is the greatest common factor, and this is the other trick here. You can factor out the x. So you get x times the log of 7 plus 2 log of 5. Almost done, but that's the second trick here. So the first trick was to distribute. The second trick is to factor out the GCF. What should I do to finish up? Yeah, divide both sides by the parenthesis. I'm not going to write that out. I'm just going to do it. 2 log of 5 divided by log of 7 plus 2 log of 5. Now, I've done this before with my intermediate algebra classes. I give them a challenge. I'm like, okay, calculate that number. And I get answers that are all over the board. So let me help you calculate it. And let me make a suggestion here for us. Let's first of all bring the 2 up. If I brought the 2 up, I'd have the log of 5 squared. Well, what's 5 squared? 25. So it would be the log of 25. And in the denominator, I'd have the log of 7 plus a log of 25. So at least that looks a little bit better. But I can make this even better in the denominator. Log of 25. Is there a way I can bring those two together? You don't have to show that step, but there is. How can I bring those two together? This is the sum of the logs. It becomes the log of the product. 7 times 25 is 175. So the 2 comes up, it'd be 5 squared, and 5 squared is 25. So let me add in an extra step here. Yes, yeah. So let me add in an extra step here. That'd be log of 5 squared over log of 7 plus log of 5 squared. And then you can go down here. 7 times 25 is 175. So you could calculate it from here. Great question. Can't you just minus these? The answer is no. The minus, there is no logarithmic property for one divided by another, unless you're talking maybe the change of base formula. No. So what you're thinking of, and I know it's tempting, it's really tempting, but the log of A divided by B is the log of A minus a log of B. But does that apply here? No, because the difference is you have the log of this whole thing, not the log of the numerator divided by the log of the denominator. So they look close, and they always get confused. So, I mean, don't feel bad. I mean, you've got plenty of company. But you can calculate it from here or here. All right, does anyone give me a decimal value on that one? 0.6232. Okay. You can check these just like before. You can check your answers back up in the original problem just by entering in that decimal or storing it. Let's try a couple more here. Actually, one more. You know, I kind of want to do another one like that. Don't tell anyone, but I'm going to do one of your homeworks, okay? Let's try problem number 35. Two to the 3x plus 1 equals 3 to the x minus 2. So, pretty similar to what we just did. Start out by taking the log on both sides. Now you can, if you want, try and play around with log base 2 or log base 3, but it's, you know, in the end, you're still going to be stuck with the log of something. You're not going to be able to get everything to cancel out. So I'm just going to use log base 10. Be careful when you take those exponents out in front. Take them out with parentheses. and see what you can do from there. So if you're watching this at home, we're in a timeout. second insert parenthesis here, and then right here, close off the numerator, so second insert parentheses. So that's just grouping together the entire numerator. Let's move over here, and I do the same thing in the denominator. In fact, you do it. Second insert left parenthesis. Or right parenthesis. You don't need it. I hit enter. Perfect. That's, now you can store that. Store x, and then you can check that 2 raised to the 3x plus 1 gives you 1 thing, and then you should get the same thing with the 3. That's okay. That checks. So, if you store that in x, and then you do 2 raised to the 3x plus 1. That's raised as far as you can take it. X minus 2.
What's that? This is 1/9.
Is that cool to be able to check your answers like that?
Yeah.
Let's just do a little sound check. Ah, cool. We still have sound. Okay, so lengthy timeout. Let's do it this way. Okay, so the big thing to do here is to distribute. This was one of a couple key steps that we mentioned in the previous problem. That is, distribute this to both of these terms. So I'm going to get 3x times the log of 2 plus 1 times the log of 2. In other words, this down here. Likewise, this term needs to distribute itself to both of these terms. So x times the log of 3 minus 2 times the log of 3. And that gives me x on two different sides of the equation. I have x on the right-hand side and on the left-hand side. So what I'm going to do is kind of move things around. I want to put my x's together. I want to put everything else on the other side. So when I move this to the other side, what changes when I move x log 3 to the other side? It becomes negative. Good. It changes sides. It changes signs. Likewise, this will become negative. So I'll have a minus log of 2 on this side and a minus x log of 3 on that side. So if you're keeping track of things, here's my two log terms. This term, when it moved over here, became minus log of 2. So the first trick was to distribute. The second trick comes up next. I need to factor out that GCF. So factor out that GCF. That gives me this. And then last but not least is to divide both sides by this term here. Now I think I played around here. I moved the 2 up into the numerator, or into the exponent. 3 squared is 9. So I'll divide minus log of 9 minus log of 2 by 3 log of 2 minus log of 3. And then you can play with this and try and simplify it if you want. You can write that as minus log of 18 divided by the log of, what would it be, 8/9 or 8 over 3? If you wanted to simplify it, you should get numerically on your calculator, and I just calculated it from here, about negative 2.94 or something like that. I took the 2, made it the exponent. 3 squared is 9. So I just left the negative out in front.
Could you also write it as log of 1/18?
Yep. You could write it as log of 1/18. So
When I tried to plug it back in, I didn't get the same result.
when I calculated it, I got negative 2.946. And to check it, I'll hit the store key, lower left-hand side, right above the on button. Store it in X, which is right next to the alpha key. If I store it in X, then I can kind of take my time about solving it or checking it. It's 2 raised to the 3x plus 1. That's the left-hand side. Let's compare that to the right-hand side. Now, x still has my variables, value, negative 2.94. X, 3 to the x minus 2. And I get the same decimal value both times. So, pretty confident that we got that one right. All right, let's do a little bit of logarithmic equations. Logarithmic equations can be solved in a couple different ways, and we will go over both of them, time permitting. We'll start with the friendliest one first. This is logarithmic equations. And I'll call it method 1 just for the sake of a name. In its way, it's kind of reminiscent of what we did with exponential equations. If two things are equal, say the log of A equals the log of B, then A equals B. It looks as if you can cancel the log on both sides. That's not what's happening, but it looks that way. So what's an example of something like that? Well, let's take a look at problem number 50. Log base 5 of x plus log base 5 of x plus 1 equals a log base 5 of 20. Can I just cancel out the logs everywhere? No. It'd be a quick way to help me grade your exams. It'd be very easy to grade it if you just canceled out all the logs. It won't work. Now, this idea doesn't really come to play yet because I don't have the log of something equals a log of something else. But I can get that. You can collapse these things as the log of 5 times log base 5 of x times x plus 1 equals a log base 5 of 20. What did I do there? I used my product rule. So I collapse those two things together. And now that I've got the log of something equals the log of something else, now I can get rid of the logs. Now, close your eyes if you're of the mathematically faint of heart. I'm going to show you a step that you can give me for extra credit. You don't have to show this step. It's a little bit challenging. If you don't want it, that's fine. But really what's going on is this. You're doing 5 to the log base 5 of x times x plus 1 equals 5 to the log base 5 of 20. You're raising both sides to the power 5. Now why? Well, why is going back to our properties of logarithms, and that is these things cancel each other out. So you're just left with a 20 and an x times x plus 1. I'm more than happy for you guys to just skip down here. If you want to show this step and show it accurately, that's an extra credit point. That's great. Because it means you understand that there's a little bit more going on than just canceling the logs. But this works too. Let's finish up the rest. X squared plus x equals 20. We don't have to pull out the rational root theorem to solve this one. This is just a quadratic polynomial. Let's factor, set it equal to 0, and solve. You get two possibilities. X is negative 5 or x is 4. Now I mentioned possibilities, and I do mean possibilities. Why wouldn't one of them work? It's a good question. The reason why one wouldn't work goes back to our work with logarithms. Think about the domain of the log function. We discussed that a little while ago. What do you know about the domain of the log function? Here's a graph of ln of x. What's its domain? 0 to positive infinity. Bonus points, thank you. 0 to positive infinity. You can't take the log of 0 or anything less than 0. -5 doesn't work because when you put it into your original equation, you end up trying to take the log of a negative number, and you can't do that. So with these, you have to check your solutions. Now 4 doesn't create such problems. 4, you're okay. Now you can check it a little bit more exactly than we're doing, but the minimum you have to do is you have to check and make sure that you don't take the log of a negative number. So, yeah, -5 doesn't work. 4 does, because you don't end up taking the log of a negative number. Now, if we had an expression just like this, you could use a negative solution, you know, depending on the problem, but you could have a -1/2, because -1/2 plus 1 means you're taking the log of 1/2. It's okay to take the log of a positive number. So there's nothing wrong with a negative solution. The problem is taking the log of a negative number. Let's try some more from this section. We'll do another one like that. Problem number 52. So this time we're working with the ln. ln of x minus 1/2 plus the ln of 2 equals the ln of, no, equals 2 ln of x. So kind of like the last one, before we start, you know, getting rid of the logs on both sides, we have to clean things up. I'm going to first bring these two terms together. This is the ln of x minus 1/2 times 2. And on the right-hand side, I get 2 ln of x. You can distribute that too. In fact, it makes a nice little difference. You get 2x minus 1 equals 2 ln of x. I can't get rid of the logs yet. You can't cancel logs on both sides if that's the way you like to think about it. Why not? I got that 2 in front. Exactly, thank you. We're going to move that 2 up. So this becomes ln of 2x minus 1 equals ln of x squared. I'm not going to bother trying to show that little extra credit step here. Now that I've got it as a log of something equals a log of something else, let's just jump to the equation. What equation pops out of this?
X squared minus 2x.
Yeah, 2x minus 1 equals x squared. Move everything to the right-hand side. 0 equals x squared minus 2x plus 1. That factors as x minus 1 times x minus 1. And it only has one solution. X equal 1. If you check it back in the original problem, x equal 1 works. Okay, let's call it a day here. I want to get you out early. For homework, try problems 11 through 35 and 49 through 53. See ya.